The dreaded bomb cyclone finally arrived, bringing blizzard conditions and coastal flooding. With forecasters warning people to expect the unexpected, even Florida's iguanas were left stunned.
The intense cold and potential for power outages has officials stressing safety and patience.
But bomb cyclones themselves aren't unique. So why is the scientific community freaking out about this one in particular? A bomb cyclone is described as a storm that subtly intensifies following a rapid drop in atmospheric pressure that occurs when a cold air mass and a hot air mass collide. And
the thing I think that caught meteorologists' attention was how quickly the models forecast this storm to deepen. The pressure is dropping so rapidly in the storm that it's really putting it into one of the strongest storms and one of the deepest storms on record in the North Atlantic. So it falls into one of the most intense bomb cyclones that we've seen. So the obvious question is, what's causing that?
That's Paul Huttner, chief meteorologist at the Minnesota Public Radio. He has been studying the weather for over 3 decades and says that this bomb cyclone is making scientists ask larger questions about changing weather patterns.
The best answers we can see so far are a very warm ocean combined with this Arctic air mass that's coming further south.
When a warm ocean is combined with very cold air, that sets up a great temperature contrast across the storm. And this contrast provides a power boost for the storm to deepen.
The greater the temperature contrast, the deeper the storm. That's the meteorology of it. The climate question is a warmer ocean creating a stronger contrast and pumping more moisture and making these storms deepen more rapidly?
While there are several studies confirming that the ocean's temperatures are rising rapidly, there might be a larger phenomenon at play here. The jet stream, also referred to as the polar vortex, and changes in the jet stream might be pushing cold Arctic winds further south than previously observed.
Jet streams steer weather patterns, steer storms throughout the mid-latitudes, especially in winter across the United States. So as you change the jet stream, you're changing the nature of storms. And that's something that we're really looking at.
A recent study published by the American Meteorological Society found that the jet stream might be weakening, causing cold air from the Arctic to escape and move to lower latitudes.
The way the jet stream has put this air down so far into the deep south is fairly unusual.
This is contributing to the severity of the winter and winter storms, not only in North America, but Europe as well. And Huttner says it's what's keeping many climate scientists up at night.
When you change the physics of the atmosphere, when you make it warmer in the Arctic, what happens to the jet stream? That's the, trillion-dollar question. The early research says that it's making the jet stream more erratic and more wavy, and that affects weather patterns in the U.S. I like to say what happens in the Arctic, it doesn't stay in the Arctic.
So, should we be worried about how these changes might affect future winters?
Those of us that are witnessing weather patterns on a daily basis are already noticing the changes. Those of us that know enough about climate to draw the links into why that may be happening are pretty concerned about 20 to 30 years down the road. What is the jet stream going to look like? How is it going to create more extreme weather patterns? And how will cities and people and civilizations be affected by that?
Hey, NBC News viewers, thanks for checking out our YouTube channel. Subscribe by clicking on that button down here and click on any of the videos over here to watch the latest interviews, show highlights, and digital exclusives. Thanks for watching.